We're asked in this diagram, after we filled it, what the three lines add up to. So what I'm going to do is actually add them up in theory. So when I add them up, I'm definitely going to add up the numbers from 1 to 9. So you can do a sum of that. There is actually a really quick way to add up the numbers from 1 to n, which I'm going to share with you. It's to use the formula a half n times n plus 1. It's worth knowing this for situations such as this. So here I just do a half times 9, my final number, times 10, which gives 45. It's great because you can even add up the numbers from 1 to 100 in moments, because this would be a half times 100 times 101, which becomes 50 times 101, which is 5050. In fact, there's a famous story about a young boy at the time called his name was Carl Friedrich Gauss, about how he managed to do this in school one day. He went on to become one of the greatest mathematicians of all time. So we've got 45 here. Right, that's what happens when I add them all up. And I'm then going to add the 5 an extra time because I'm going to get the 5 from this line, but also this line. And the same with the 2, and the same with this one up here, x. Now x is going to be 1 to 9, except not 2 and 5. I don't know what it is, but it's there. So that gives me 52 plus x. Now I require for this to work this number to be divisible by 3. So it must be that x is equal to 2. That would get me to 54, which is divisible by 3. Or 5, that would get me to 57. Or 8, and that's it. But the thing is, I've already used 2 and 5, so it must be that this is 8. And therefore my total will be 60, which means when I divide it by 3 for each line, I'm going to get 20. I strongly recommend spending some time getting your head around this method and applying it yourself to different questions. I see lots of JMO, the Olympiad problems, where you have to use these ideas and you have to say, for example, how many different ways can the grid be filled? So they add extra bits of maths in. They've not actually asked us to fill it here, but we're now going to do that. So we know that the total is 20. I've got 13 here. Oh, let's just write down the numbers I have left to use. This is just a little bit of bonus now. Like in theory, we've shown that if it's going to be possible, we need to have 20 along each line, but we've not actually shown that it is possible. So we've got 6 numbers left to fill. So here I've got 13. I need to get to 7, so maybe I could put 6 and 1 in. Then here I've got 10, so 7 and 3 would work. And then here I've got 7, so 4 and 9 for 13. And you can see like you could swap these around. There's different ways you could arrange it. But I think, well, maybe we could use the 3 and the 7. Sorry, the 3 and the 4 here instead. So there's actually lots of different ways to fill it. You might be able to get there using trial and error, but it feels like a bit of a brute force method. And, you're going to have to luck out at some point that is going to be 8 because that is the only way it will work. All right, well done.